Today, TCP and its visionary CEO Ellis Yan have revolutionized energy-efficient lighting around the world, and in the process are redefining lighting's role in global climate protection. TCP produces more than 1.5 million CFLs every day, accounting for the majority of CFLs on the U.S. market and an annual reduction of 118 million pounds of carbon dioxide. With its global headquarters located outside of Cleveland, Ohio, TCP's manufacturing arm is in Yanzhou and Zhenjiang, China, where it owns and operates manufacturing facilities employing more than 15,000 workers. TCP is unique in the industry because it controls all aspects of the CFL manufacturing process, ensuring each product is of the highest quality. TCP operates 5 glass-making furnaces, which use a combination of sand, crushed recycled glass, soda ash, limestone, and other raw materials to produce as much as 60 metric tons of glass each day. The glass is shaped into tubes and cut into pieces. Each tube must be framed, a technique that uses hot gas at 1,000 degrees Fahrenheit to smooth the rough edges. Once the framing is complete, the glass tubes are ready to be twisted into the CFL's familiar spring shape. The bending, once done entirely by hand, is undergoing a significant transformation that will reshape the energy-efficient lighting industry. TCP is innovating the product category with the development of the industry's first automated machine to bend the glass. This is a major milestone for energy-efficient lighting. By automating the process, TCP can dramatically increase its capacity and supply the rising demand for CFLs around the world. Each machine produces more than 5,500 pieces a day. That is nearly 5 times as many produced by the company's hand benders. The automated machine has helped streamline manufacturing, allowing the company to operate more efficiently. Automated bending is an exclusive manufacturing process that only TCP can provide to its customers. Keeping in line with TCP's commitment to sustainability, bent glass that does not meet specifications is sent back to the furnace to be melted and recycled into the CFL manufacturing process. Once the CFL passes this stage, the legs which connect the glass to the base of the lamp are then created. The bent glass tube is now ready for the coating stage. TCP is the only manufacturer to pre-coat the spiral glass with titanium dioxide, which acts as a buffer between the glass and the mercury. By using this patented nanotie technology, the mercury is locked into the CFL and cannot penetrate through to the glass. This exclusive process is critical to reducing the amount of mercury in each CFL, making it an even better lighting choice for the environment. The glass tube is also chemically pre-coated to prevent a reaction between the glass and the phosphor coating, which is added next. The CFLs are loaded onto a horizontal rotating machine that evenly coats the glass with phosphor. This is an exclusive process to TCP. All processes within the coating stage improve lumen maintenance and overall optimized lamp performance. TCP is continuously examining its manufacturing process and incorporating new innovations that create products with minimal environmental footprints. After the coating inspection is complete, the CFLs are loaded onto a roller conveyor, which transports them through an oven and then through a cooling chamber. As the tubes pass through the oven, the phosphor coating is baked onto the glass tube. The coating and baking are critical steps in preventing lumen depreciation over the life of a CFL. Now that the glass of the CFL is complete, the next step is to add the filament. Each filament contains a stem and hook. The hook is dipped in electromagnetic powder by an automated machine that applies precisely the correct amount. The electromagnetic powder is very important in the manufacturing process as it determines the life of the CFL. When the powder runs out, the filament burns out and the CFL no longer works. Therefore, if too little electromagnetic powder is applied, The CFL will not burn for the entire 10,000-hour life of the lamp. The filament is inserted into the glass CFL. The CFLs then pass through an automated sealing machine that rids the glass of any impurities, keeping it as clean as possible for optimum performance. At this point, argon gas is repeatedly inserted through the inside of the CFL to make it as pure as possible. The more pure the lamp, the better it will run up and maintain lumens. This helps extend the life of the CFL. Mercury is necessary for a CFL to operate. It is the mercury that is quickly heated and vaporized in the glass tube. The mercury excites the phosphors, causing them to glow and give light. TCP was the first manufacturer using 100% amalgam, a small pill which is a solid-state form of mercury and other elements. Amalgam is much easier and more accurate to dose. TCP's CFLs use less than 1.5 milligrams of mercury, a 70% reduction below the Energy Star mandate of 5 milligrams. The CFLs are loaded onto a rotating machine and automatically tested for quality. This stage also confirms that the filament is not attached to the inside of the glass. While the glass is the part of the CFL that glows and gives light, the ballast is what drives the lamp. Included in the ballast is a circuit board. The automation of the circuit board is yet another improvement TCP has made to the manufacturing process. The European Union's Restriction of Hazardous Substances, or RoHS, bans the use of 6 hazardous substances in electric and electronic equipment, including lead. The PC board and the wave soldering do not contain lead, which is an important development in making TCP's CFLs RoHS compliant. The next step is the assembly of the ballast and plastic housing. Once the plastic housing is complete, it is glued to the glass. A high-speed printer labels the ballast with the necessary product, contact, and name brand information. After the CFL is assembled, it is burned for 2 hours, 1 hour base up and 1 hour base down, before it is packaged and shipped to TCP's customers around the world. TCP has a dynamic international team designing, manufacturing, and distributing the highest quality CFLs on the market. The company's long-term commitment to sustainability is at the core of every aspect of the manufacturing process, which is simply unmatched in the industry. TCP is ushering in the next generation of lighting, and consumers around the world are taking note. The lighting revolution has arrived, and TCP is leading the charge.